So in this tutorial, I will talk about plotting using HiVis. So in this notebook, I'll show you all the plotting methods that are available for both HiVis and the aggregation um, type objects. So first we start by loading the data that we previously worked on. We also have the subset of the data with the single cell. Again, you can have it on your whole data, but for demonstration purposes, I'm only doing it on subset. So the first plot is the spatial plot. So in this, we just call the object dot plot dot spatial. Generally, all the plots are accessible via dot plot method. So if we just plot it, we see all the tissue that we have, and we can also decide which resolution we can use. So we have the low, high, and full res. Of course, if you are zooming in, so here we use the X lim, Y lim, so we specify the limits. Those are in microns. So what you can do is you can do here axis labels equals true. And then you will have all the micron labels. And then you can specify, for example, I want only this. So I can specify xlim and ylim. And then very easily I can plot only this. Of course, if we are using low resolution, it's not good if we are zooming in. But here, for example, this is low resolution and you can't even tell because it's so large. But usually if you're plotting close, you should use the full res. You can also plot stuff on top of this. So you can plot orbs or the expression levels of genes. And you do it, here is an example. We have the gene, for example, ADA. And we plot it first. This is just the normal plot. So we do our object.plot.spatial and specify the gene. And in this case, the argument exact will be false. This is the default. This means that the general, the place of the bins is correct, but the size isn't exact. So the spots can overlap and so on. This is very fast. So you can also plot it on the whole slide relatively fast. But if you want a very nice and exact values, you need to use the exact equals true. This takes more time because each one is plotted individually, but the size of each bin is 2 by 2 micron exactly. So use it if you are zooming in. And also the single cell object or the aggregation object also have spatial plot. Then we will have those spots in the place of the cells. So let's see a few customization stuff we can do. For example, here we can change the colors of the cells. We can change the size. We can change the scale bar, color, size, text, and so on. We can remove the text. We can do with or without the axis labels. We can do with or without legend. We can change the colors, of course. We can change the alpha. So here, this is not transparent. Here it's transparent. So alpha 0.5. The colors can be either ready color map, for example, winter here, or you can specify a list of two colors. For example, here we have black, purple, and yellow. So the colors go from black to purple to yellow. Or if we are plotting a categorical observation, we can also specify a dictionary. For example, proximal intestine is green, distal intestine is red, for example, and so on. What else? So yeah, and we can plot the image or not. We can specify like before the image resolution, and we can change the contrast and brightness. For example, here the brightness is very high now. Titles of the legend, X label, Y label, everything is customizable here. And also each of those calls actually returns an ax object. So you see that we can specify the ax inside, so we can create the ax before, but also this function itself returns an ax which you can modify using all the matplotlib functions, which is everything. So the next plot is histogram, pretty straightforward. So we can plot in the single cells or the object itself, the bins, and it just counts how many we have in each one. So for example, this is the laden clusters, and we see how many cells we have in each laden cluster. This is the number of UMIs per bin, and this is also the bins in the different categories. So in the histogram, you can also specify the limits. So if we look, this is all the bins. Here, this is the same plot as this, but we specify the xlim. So you can see here, we have the xlims. This is just cosmetics. But if we actually want to plot only specific range inside our spatial coordinates, this is done like this. So we first plot the spatial using the xlim ylim. This is actually cropping the plot. So we saw here, all of this is with xlim ylim. And then if we specify in the histogram cropped equals true, it will actually count only the bins in the region that we specified. So this is usually not too useful, but just keep in mind. Also, we can customize everything as before. So color, yeah, the colors, what else? Labels and so on. The next plot is the correlation plot. So this is very useful analysis. Uh, you can do it for both the HiVis and the single cell. And what you do is you plot the correlation of a gene. For example, we take the gene IgHA. This is a B cell plasma cell marker. And we plot the correlation. And we see that the genes that have the highest correlation of 0.7 almost, those are also genes that are specific to plasma cells, which makes sense. We can specify the color, the number of text that we can display, and so on. This is very useful to find genes that are going together with something interesting we found. Now, additional correlation is if we have several genes and we want to see the relationship in the spatial context. And this is done in the same function. This is plot core, but instead of one gene or one obs, we specify a list of genes. And then we see this. So for example, high correlation is green, and we see that all the markers of PANF cells are actually clustered together, and all the B cell markers are clustered together, and so on. So the next plot is the plot of cells. This is very useful. And what it does, it requires the geometry in our object. The geometry I showed you before when importing the single cell data, it's actually imported with the GeoJSON. So you can do it directly when creating the object or by using the import geometry function. And when you have this, you can do the plot cells. Here you can see the plot, only the outline of the cells. This is useful to assess segmentation. But also you can plot a gene. For example, here we have ADA. Notice that all of those cells here have zeros, so they're transparent. We can also say that show zeros is true, and then they will be colored. And we can plot also observations, laden clusters, and so on. Yeah, so the next plot is UMAP. So in this case, we are plotting the laden. So we have single cell dot plot dot umap laden, and if we use the text, we will have the text on the plot itself. now if we are plotting a gene, we will have the expression level. We can change the size of the dots and so on. It's also fully customizable. You can play with it, or you can just use the Scanpy plot UMAP. The last plot I want to show you is the noise mean curve. This is also a very useful analysis, and the plotting here helps very much to find interesting stuff in our data. So we are doing this by our object.plot.noise mean curve. I think it can take a little time in the first time you run it, but afterwards you can plot it instantly. And you can also do it on the single cells. Here, what you are seeing in this plot is the expression level by the log 10 CV. So the genes that are far away from this curve, those are the genes that change in the spatial context. So for example, this gene is a plasma cell marker. Why it's here? It's because the plasma isn't distributed equally in the space. So this is very useful to find genes that are bursty or changing only in some space in our spatial data. Also, this is very customizable. You can specify the degrees of the log. You can color everything. You can see more text and so on. You can go to the customization, to the documentation and see all the options that are available. So now we have all of those. And as I said, all of those methods actually return an axe object. So now what we can do is we can actually plot several things together. For example, here we plot the cells with their classification of muscle or tissue. So in red and purple, we will have those cells. But on top of it, also, yeah, we can have a legend added here by using the add legend, but you don't have to do it. But on top of this, we actually plot a gene, for example, ADA. So those are actually the spots, the 2x2 bins plotted on top of the cells. This is very useful when doing subcellular analysis, for example, which you can see in my paper. And here you can also see how to combine different colors. So here we have 3 different genes, and each one of them has different color map. So ADA here in the tip of the villi, DEFA in the panel cells in the crypts, and the muscles here on the right side. Everything, of course, is still customizable, so you can customize each one individually, or you can customize the figure itself. You can do subplots and so on. So again, it's very, very flexible.